Welcome everyone. In this part, I am going to discuss about production of ultrasonic waves. So in my previous video lecture, I discussed about the introduction of ultrasonic, and here I am going to discuss about production of ultrasonic waves. Basically, I will discuss about two different methods. One is magnetostriction method and another is piezoelectric method. Basically, these two methods, magnetostriction method and piezoelectric method, are very useful to produce ultrasonic waves. But when we are talking about the production of ultrasonic waves, generally generating ultrasonic waves is to cause some dense material to vibrate very fast. The vibrations produced by this material then cause the air to begin vibrating with the same frequency. These vibrations then spread out in the form of ultrasonic waves. So in general, to produce ultrasonic waves, so all you need to cause some dense material to vibrate very fast. So here we are going to discuss the magnetostriction method. So now, what is the principle of magnetostriction method? When the magnetic field is applied parallel to the length of a ferromagnetic rod made of ferromagnetic materials, for instance iron or nickel, a small elongation or contraction occurs in its length. So you can see here, so this is actually the ferromagnetic rod up to here, and this is the magnet, the north pole and the south pole, and the magnetic field is along the parallel to the length. So now when we apply magnetic field, depending on its strength, so you can see this is actually the small elongation or the small change, this which is in the brown color. So this is the change due to the magnetic field. When you go near the transformer, you can hear a humming noise. Magnetostriction is the second source of this vibration, in which the core iron changes shape minutely when exposed to magnetic fields. And here the fundamental frequency of this humming sound is usually double of the fundamental line frequency, that is, you can say the double of the 50 Hz, so that is 100 Hz. Now the change in length of the rod depends upon the strength of the magnetic field, the nature of the ferromagnetic materials, but it does not depend on the direction of the magnetic field. So now I will discuss how we are going to produce the ultrasonic waves or the ultrasonic sound using this magnetostriction method. So let's say this is the rod. What you can say that this XY is the rod of ferromagnetic materials. You can use iron or nickel or any other ferromagnetic materials, and then you can clamp this rod in the middle. The alternating magnetic field is generated by electronic oscillator. You know about electronic oscillator. I have discussed about electronic oscillator or the resonant circuit in the waves and oscillation sections. The coil L1 wound on the right hand portion of the rod along with a variable capacitor C, and this actually forms the resonant circuit of the collector tuned oscillator. The frequency of the oscillator is controlled by this variable capacitor, which is C here, and the coil L2 wound on the left hand portion of the rod and connected to the base of the circuit. The coil L2 acts as a feedback loop, and this is your high tension battery. Now as soon as we switched on the high tension battery, the collector circuit oscillates with a frequency of F is equals to 1 by root over L into C, and here L is actually L1, so you can write it, the frequency is equals to 1 by root over L1 and into C. This alternating current flowing through the coil L1 produces an alternating magnetic field along the length of the rod. The result is that the rod starts to vibrate due to the magnetostrictive effect, and the frequency of vibration of the rod then will be equals to 1 by 2 into L into root over capital Y by rho, where L is the length of the rod, capital Y is the Young's modulus of the rod material, and rho is the density of the rod material. Now the capacitor C is adjusted so that the frequency of the oscillatory circuit is equal to the natural frequency of the rod, and therefore resonance takes place. So that means at resonance the frequency of the oscillatory circuit is equal to the frequency of the vibrating rod. Now the rod vibrates longitudinally with maximum amplitude and generates ultrasonic waves at high frequency from its end. So now we will see what are the advantages and disadvantages of this method. So the main advantages of these methods are the design of this oscillator is very simple and its production cost is low. At low ultrasonic frequencies, the large power output can be produced without the risk of damage of the oscillatory circuit. And the disadvantages include it has high low power frequency limit and cannot generate ultrasonic frequency above 3000 kHz. The frequency of oscillations depends on temperature. There will be losses of energy due to hysteresis and eddy current. The second method is piezoelectric method. So now first we'll talk about principle of piezoelectric method or the principle of piezoelectric effect. If mechanical pressure is applied to one pair of opposite faces of certain crystals like quartz, equal and opposite electrical charges appear across its other faces, and this is actually called piezoelectric effect. So here in this cartoon and in this figure you can see that so when you apply a mechanical pressure to one pair of opposite faces of some materials, equal and opposite electrical charges appear across its other faces. The converse of piezoelectric effect is also true. That means if an electric field is applied to one pair of faces, the corresponding changes in the dimensions of the other pair of faces of the crystals are produced, and this is known as inverse piezoelectric effect or electrostriction. So here in this cartoon you can see that we are applying electric field, and this electric field is actually changing the dimension of this cylinder. The examples of piezoelectric materials are titanates of barium and lead zirconate. The chemical formula is PbZrO3. There is ammonium dihydrogen phosphate, which is NH4H2PO4, quartz, which is actually a natural crystal. Also, human bone exhibit piezoelectric properties, meaning that when stress is applied to the bone produces a current within itself. So now, how we are going to produce the ultrasonic waves? So here we are going to place the quartz crystal in between two metal plates, that is A and B. The plates are connected to the primary of a transformer which is inductively coupled to the electronic oscillator. The electronic oscillator circuit is a base tuned oscillator circuit. The coils L1 and L2 of oscillator circuit are taken from secondary of a transformer. The collector coil L2 is inductively coupled to the base coil L1. The coil L1 and variable capacitor C1 form the tank circuit of the oscillator, and this is the high tension battery. Now, similar to the magnetostriction effect, when high tension battery is switched on, the oscillator produces high frequency alternating voltages with a frequency F is equals to 1 by root over L into C. Again here L is equals to L1, so this is actually 1 by root over L1 into C. Due to the transformer action, an oscillatory EMF is induced in the coil L3. These high frequency alternating voltages are fed on the plates A and B. Inverse piezoelectric effect takes place and the crystal contracts and expands alternatively. The crystal is set into mechanical vibration. The frequency of vibration is given by N, the frequency of vibration here, that is the mechanical frequency, is equals to 1 by 2 into L, which is small l, into root over Y, that is the capital Y, divided by rho, where small l is the thickness of the crystal, capital Y is the Young's modulus of the crystal, and rho is the density of the crystal. Now, the advantages of these methods are ultrasonic frequencies as high as 500 MHz can be obtained with this arrangement. The output of this oscillator is very high. It is not affected by temperature and humidity. And the disadvantages are the cost of piezoelectric quartz is very high. The cutting and shaping of the quartz crystal are complex. So that's all for today, and in the next class I will discuss about the application of ultrasonics.